So you can see that we've been able to analyze all the fundamental quantities and their units. Fundamental quantities and their units, respectively. We must know that we have the quantities, and we equally have the what? The units. I want to clean the board so that we can talk about derived quantity and units. If you see what we are having here on the board, you see that I'm actually bringing out these three. These three are the ones we use to derive so many other quantities. Sorry, to derive the unit of other quantities. So let me clean the board so I can go to derived quantity and what? And unit. Derived quantity and their units. Now, in derived quantity and units, there are so many other things that we need alongside with it. We need a formula to give us a direction of how it will look like. I will start with derived quantity. Derived quantity. Then formula. Because it is formula that will tell you how the unit will be derived. Without a formula, you don't know how the unit will look like. And that's where most people don't always have problem. How did you do this one? This one is very difficult. How is it done? No. Understand it clearly that why, before we talk about the right quantity and the unit, you must bear this one in mind. Number one, mass, which we know as what? Meter. Then we have length, which we know that the unit, the first one is kilogram, the unit of mass is kilogram, while the unit of length is what? Meter. Then the unit of time, time is what? Seconds. So these three, we are going to play with them. Like I was teaching some persons, I said, when you are dealing with physics, in mathematics we know that what is length times breadth in rectangle is length times breadth, times breadth. But in physics we don't see it from that angle. We see that any quantity we measure, we have to measure from one end to the other. We make use of length. So irrespective, for example, now if I'm dealing with a rectangle, for instance, I'm dealing with a rectangle, I'm not going to regard this one as my length and here as my breadth. Or every one of them is what? Is length, because I'm measuring from here to here. I'm measuring from here to here, from one end to what? Another. So that is why you will see that in physics also, distance is also regarded as what? Length. So we use the unit of length to derive distance. So any kind of quantity we measure from one end to another, we don't regard it as like we have in the case of a mathematics, we say this one is length, this one is breadth. No. Any quantity we measure from one point to another, we regard them as what? Length. So we'll go with the first one, which will make other ones easy for us. Area. Area, formula for area is equal to what? Length times breadth. This is just a general formula for a rectangle. This was used to derive other formula for other shapes. This formula, length times breadth, was used to derive for other shapes. But for the simplest of all, is the formula of a rectangle that is used, which is length times what? Breadth. Like I said earlier, in physics, that breadth is length, length is what? Length. So we're going to use the units. We're going to use the unit of length in both cases. Please take note of that. That in the place of the respective quantity, because the formula will give you different quantity at this time. So in the place of the respective quantity in the formula, we're going to slot in what they represent in the formula. Like in the case of length, the unit of length is what? Meter. In the case of breadth, in the case of breadth in our is also what? Length. So it's still going to be the unit of what? It's going to be what? The unit of what? Length. Which will now give us meter it's always in a square form. It's courtesy of the formula that help us to derive the unit of what? Area. That is why it is like that. Because of that. So we'll go to the next one, which is volume. In the case of volume is equal to length times breadth times height. Not for all shapes. This one is particularly for keyboard. But because keyboard happen to be the simplest of all the shapes, like is now used to derive order for general formula for order. I mean, this formula is used to derive for orders as well. They have their own formulas. Like the formula for comb is different. Or pyramid has similar formula. What is the formula? 1/3 base area times. Right, it's a general formula. Don't worry, we won't get to that. We're not talking about mathematics, I will come to that. Now, this is just for this. Let's focus on this first. Like I said earlier, in this situation, with the unit of length is what? Length. We are using the respective unit for each of the quantities now that form the formula. The unit of length is what? Meter. The unit for breadth is what? Meter. The unit for height is what? Meter. When you do this, mathematically you are going to what? MQ. That's why you see, like I said before, when you see somebody write 3 meter cube, you don't need anybody to tell you that the person is talking about volume. When the person tells you 3 centimeter cube, you don't need the person to tell you that the person is talking about volume. When you see somebody write 200 millimeter cube, you don't need anybody because the unit automatically has defined the quantity you are talking about. That's a very good reason why your unit must be attached to whatever value you are getting. Then we have the next formula I want to talk about is density. Density, because we have a full formula for volume already, we have already derived the formula for volume. Density is just simply mass per unit volume. Mass per unit volume. So mass over volume, that's what we are saying in a nutshell. So from there you can see that you can go back to those 3 units and quickly pick out the unit for these 3. Don't forget. So we see the one that matches our formula from the 3. Now we go back to it. You will see that mass, we have it directly there, which is in kilogram. You are going to see, let you see this over volume. Now we've already derived volume like this already, previously in our formula. It's just for you to break it down based on the formula. Based on the formula, mass over volume. Based on the formula, mass over what? Volume. So we now have meter cube. That's why we now have kilogram per meter cube. What's the question?
Can you not write it as kilogram meter cube?
It's wrong. You see the formula now? Mass over volume. If you are writing it like that, means that you are saying it's going to be kilogram times volume. Do you understand now? So by the formula defines how the unit will be. Do you understand? So the formula gives you a direction. In fact, you don't need to rack your brain. It comes naturally the way the formula comes. The quantity, the way they are presented. Can you see? Because look at it now, very simple. You see, mass is there, up there. Then the volume is what? At the denominator. So it's kilogram over volume. In physics, we use the term. We don't say over. We say kilogram per meter cube. That one will be by kilo. So it's based on the formula that guides you on how the units will be. Very simple. You don't need to disturb yourself. It's based on the formula. The formula guides you. Right? So let's go to the next formula. What is the next formula? No. Let me go to the next formula. I don't need you to tell me. Let me just talk about let me talk about time. No. Time does not have a formula directly here. Let's go to speed. Speed is equal to distance. Distance over time. Distance over time. Speed is equal to distance over time. And we know from the our three fundamental quantity we are using, that the one that aligns with distance is actually length. So we are going to use, I told you that our length is when we measure from 1 to 2. We are going to use the unit for distance in the place of distance now. Look at the deriving unit now, not talking about the quantity. These are quantities. Sorry. These are the formulas of the quantity. formulas of the respective quantities. And now we're talking about their unit, deriving their unit based on the formula. Here we now have meter. What's the unit of time? Is what?
Seconds.
That's why we say meter per second is actually the unit of speed. We also can talk about velocity. Velocity is very similar to speed, but we have a little difference. Maybe subsequently in our other class we'll talk about the difference. But the formula is simply velocity is equal to displacement
Over time.
Displacement
Over time.
over time. What is displacement? Displacement is actually distance, but distance traveled in a specified direction. When we're talking about vector quantities and scalar quantities, we'll go into the details of that. So if you look at the three fundamental quantities we are using, the one that aligns with displacement is actually, the unit is actually meter. Then the time is what? Meter per second. Then we go to the next one. What's the question?
Why is it not meter per second square?
I'm coming there. Can't you see that it's just time? It's just time. Do you understand? It is just time, not time squared. So it's just based on the formula. You don't change anything that you are seeing there. Do you understand?
Yes.
You don't change anything you are seeing there. It's just based on what is there in the formula. Now, what you were mistaken for this formula, I guess, is where we are going to now. Acceleration. Acceleration is equal to what? Velocity. Change the velocity by what? Time. Let's use a short form, like velocity by time. Now, don't forget we've derived unit for velocity already, which is meter per second, right? So we are going to put it directly there. Remember, we are dealing with the formulas. We are going to substitute the unit for each of the formulas. So we now have meter per seconds over what? Seconds again. This was where it's based on the formula. Look at this. This is meter per seconds. Meter per seconds velocity. What I'm saying here is velocity is equal to what? The unit of velocity is what? Meter per what?
Meter per second.
Per seconds. Then that is just for velocity, right? Just for velocity. Then over seconds again, which is time, the unit of time.
The unit of time is not
You cannot believe. So we've already, the velocity was already certified. I mean, already known as meter per second. Then over time again. Do you understand? That's why it's like that. So mathematically, whenever you have something like this, the meaning of this is simply
meter per second.
meter per seconds divided by this one is division.
Okay.
By seconds over 1. We make it a full fraction. It actually divided by seconds. The reason why we make it over 1 is that 1 does not change what is there.
Yes.
So you make it a full fraction like that. Then we know mathematically that it will not be what? Times 1 over what? X. You must know this in mathematics. These are mathematics. So when we are changing into multiplication, we now interchange the next fraction. 1 becomes the numerator, while the x becomes the denominator. So when we do this, we now have what? Meter per second square. So this becomes the unit of what? Acceleration. So you can see how we arrive at this. We have given you this mathematics principle is something that you must know. Because it's normally you're supposed to upload this in simple mathematics. This is how it is done. How we change the division to multiplication is a simple mathematics process. Now we can go on and on like that. In as much as we're able to know the formulas and you know how to derive the formulas, so if you put it in the formula, you will know the respective units of any kind of formulas. In as much as you know the exact quantity to use among those three formulas.
So
Those three quantities.
that means you're trying to say that the ones that make up the main formulas in all physics is mass, length,
Time. This is what we normally use.
So these are the main.
These are the units that we use to derive. As we go on and on, we want to derive the unit for force. We want to derive the unit of power. We want to derive the unit of momentum. We want to derive the unit for moment. We want to derive the unit for all that so many. As we mentioned those quantities in physics, the derivation is based on three.
Mass,
Yeah,
energy, and time.
I'm just telling you, it's as simple as this. And this is a very strong foundation that most people don't know. Because there is no way, there's no how you will write physics exam and you don't put your units and you expect to get anything. In fact, it's zero. If you want to mark it, you don't get anything. So I want to strongly believe that with this, you should not have any problem with calculations. I mean, with these fundamental quantities and derived quantities. Thank you very much.